Hi guys. So I was getting annoyed watching music videos on Spotify because they were recommending me the same music all the time. I wanted something different. I wanted something personalized for myself. Then I also was annoyed with the ads and I wanted something which will give me all the music videos ad free. And I like to watch music videos. I don't like the song directly. I want the video as well. So without using any premium, I created my own personal Spotify, and this is Spotiflix, basically a hybrid of Spotify with Netflix, and I'm using hybrid contextual bandits here, which will change the recommendations in real time. So let's check it out. So the recommendation pipeline goes like this. Spotify is a production-grade music video streaming platform that combines Netflix cinematic interface with the advanced recommendation system. The recommendation pipeline transforms tracks and interactions into a continuously updated user representation. It retrieves the candidates and finally re-ranks them in real time. So, how do you represent the track? Every track is converted into a 14-dimensional feature vector. Because different audio features have different scales, we standardize each feature using this catalog wide mean and standard deviation. The user vector is which represents the live personal taste in the same metric space as the music catalog. When a reward is positive, the profile is pulled towards those audio characteristics. When reward is negative, the update contributes a vector in the opposite direction, shifting the profile away from that feature region. So that's the intuition behind it. Now, the reward function converts explicit and implicit behavior into one continuously bounded scalar between -3 and +3. Explicit likes provide strong, unambiguous direction, while watch ratio, hover duration, click intent provide dense implicit feedback. Now, rather than treating all skips equally, our model centers the watch ratio so that listening to over half the song is positive and under half is negative. Then, exit context scales the outcome. Finishing 90% of the song and clicking next receives a positive bonus, while aborting after 3 seconds via back button triggers maximum negative amplification. Now, Spotify separates heavy computation from fast personalization. The offline batch jobs compute global statistics, builds FAISS vector indices, and factorize user item matrices. While in online, the incoming stream updates user profile vectors and bandit matrices in under 5 milliseconds via closed form algebra. So, let's see how our recommendation engine is created after all of this context is stored, right? So this has three profiles. First, multi-channel, then collaborative implicit ALS, and then finally hybrid LinUCB. So stage one, multi-channel. Here we reduce the 170K catalog to a small candidate set before applying the more expensive contextual ranking model. We query three channels at parallel and FAIS's content, similarity, ALS collaborative dot products, and freshness decade popularity, and then merging them into 50 top candidates. So in our implicit ALS formulation, the aggregated reward, our UA, becomes the target, while its absolute magnitude determines confidence. Strong interactions, therefore, influence the matrix factorization much more heavily than passive background events. Now, what are the constraints here? Rather than hard filtering foreign languages, Spotiflix applies a soft constraint. Out of language tracks are dampened by 85% instead of being removed entirely, maintaining high catalog relevance while keeping a discovery door open. Next step is re-ranking the 50 candidates into the final top 10 using hybrid LinUCB. The first term predicts expected reward using shared and track specific weights. The second term adds an uncertainty bonus if the model has high variance about a track under certain context. Its scores increases, balancing exploitation with exploration. Notice that the shared model is 16 dimensional, while the ARM specific model remains 14 dimensional. The additional two dimensions are session context, time of day, and queue position. Because the covariance matrices are compact 16 cross 16 and 14 cross 14, online matrix inversions execute in sub-millisecond time. Now, for new users, the retrieval mix smoothly transitions from popularity to personalization collaborative filtering over their first 50 plays. For brand new tracks with zero history, the ARM model fallbacks to the shared global model, while high matrix variance provides an exploration boost to surface the tracks to receptive users. Then our telemetry architecture comes into play, which is a continuous feedback loop of Spotiflix. Every watch ratio, exit source, hover, and like is captured client side and translated into mathematical rewards, updating the user vector and bandit matrices before the next track transitions. In summary, the strength of Spotiflix is not any single model, but the combination of retrieval, personalization, collaboration, and exploration in real time feedback loop. By unifying modern React interfaces, resilient microservices, and mathematical rigor, Spotiflix demonstrates how modern streaming platforms deliver fast, personalized, and scalable recommendations. And let's check out the demo video now. Hey guys, welcome to the demo of Spotiflix, Spotify plus Netflix combined. So here you can see there are a lot of top recommendations. Here are trending, etc. And there are a lot of Spotiflix specific picks as well. So I'll just show you a few things from my list. So you can see here you have liked songs, and these are all in the track list. Alongside that, you can also save playlist. For example, this is a playlist which I've saved, which has a lot of songs in it. And then you can create your own playlist as well. For example, happy as a playlist, and I can add a song like Lemonade, and then it's just searching for the song, and then you can just add the Lemonade song here. So that's the intuition, and Lemonade song is added in your playlist inside the stuff as well. And you can also see playlist where you can add other songs, so Hindi, English, everything is possible. And then you can just shuffle it, and while shuffling it, you will just shuffle the songs. I'll just not play this because of copyright, but yeah, as you can see, you can shuffle the song, and then in the last 5 seconds you can play the next song, and that's the intuition, and it just keeps going, it keeps going. So what happened in shuffle is that it will play the shuffling song, right? But what if you are seeing a new song for the first time? For example, I'm seeing this song, right? Then what will happen? So let's see. I don't want to play the song, so I'll just move this up again, and then let's just go here and see what happens. So it will automatically first register, and then it will automatically recommend you a song which was in a similar state, in a similar semantic from the current song. So that's how it works. Also, there is live intuition, everything is recommended live. So we were seeing English songs, Hindi songs. If I refresh right now, the recommendation should change slightly, not a lot, but there will be a slight change in the top recommendations. So yeah, it's not a lot of change, but yeah, there is a lot of songs which you can check out here. That's the intuition, and that's pretty much it.